Good afternoon. My name is Mr. Royce. It's going to be AP Statistics Friday, Valentine's Day, February 14th. We got a live studio audience here.
Look at
And
this.
here,
You got another
just
one.
pause.
This is our whole class.
For me?
Surprise.
Oh, this is so exciting.
This is it.
Thank you so much. Happy Valentine's Day.
Who's it from? Who's it from?
This one's from Cindy. Last name is spelled S-I-E.
Z.
Are they bribing you, Mr. Royce?
So,
If I got
they're
you a
just giving me
chocolate rose,
chocolate.
would
That's
you
all
give
they're
me
doing
an
is
A?
giving me chocolate. What? I'm sorry?
If I got you a chocolate rose, would you have given me an automatic A?
So that's not how things
But I'm
operate
thinking
here
of,
at Wheaton Academy, where
What is the
every
probability?
student
What is the
earns
probability?
their grade.
What if I buy you a Promethean board?
Oh.
So, well, that would be
Or
the pathway to my heart, that's for sure. So, although Wheaton Academy does have 2 extra Promethean boards that they're not currently being used, but maybe the spirit of the Promethean board will spread to other teachers, and they'll be clamoring for a Promethean board in their own room. We'll see. We'll spread the word. Let people know how much you love the Promethean board. Lydia, your question.
Do other math teachers have a smart board?
In other schools, yes, not in this school, but we do have 2 other
Does Australia
Promethean
have a
boards
smart
in the
board?
storage that could be installed here at Wheaton Academy.
Well, bring it in.
Well, what's
But
your
all 3 of
opinion
them.
on why? I mean, do you like the Promethean board?
I
I think
absolutely
it's great.
love the Promethean board. It can be a little laggy sometimes when you forget to save, but besides that, it's a really great investment to the classroom.
Well, thanks for your feedback. Let's take a look at the homework that's due today. Homework number 1. Turned out that parts A and B were just pure review. There was nothing new about
That's crazy.
parts A and B. In fact, if you take a look at parts A and B, it was just a unit 2 problem, semester 1, unit 2, where you were basically given a normal model with a mean of 12.2. Isn't this nice of the people in Jolly Time? They're shooting high. They don't want to be accused of false advertising. They're advertising 12 ounces. Have you ever had a math problem with more 12s in it? They're advertising 12 ounces per can, so they're going to say, we don't want to, we're going to shoot high. We don't want to lie to our customers. We're going to shoot high. We're going to shoot for 12.2 ounces per can, standard deviation. You realize some of them might be undersold, but standard deviation 0.14, is that what it was? Yeah, 0.14. So 12.2, you had we're defining underfilling as 12.15 or less, so you probably used normal CDF and came up with 0.3605. Is that what you came up with for part A, 0.3605?
I did.
I
Yeah.
got negative. Oh, wait, just kidding. I got
Well, the probability has to be a non-negative number,
I actually
0.3605
got 0.4473.
for part A.
Yes.
Okay,
Oh, no,
so-
that's part B, just kidding.
Right, so on part B, this is also a review problem because we're saying now, let's take 12 cans. And I'm just gonna grab the door real quick. And we're back. Now, part B on the homework, think about it. We've come up with a null hypothesis regarding 12.2 ounces. So when they say 12.2, and it really requires some deep thought in general to figure out what's our null hypothesis going to be. Is the null hypothesis going to be that the person is telling the truth or that they're lying? Our
We
null
assume they tell the
hypothesis
truth.
that mean is 12.2 ounces. And so we're going to figure out what's it going to take to reject the null hypothesis.
Ask you.
So we could reject the null hypothesis if 4 or more of the cans out of 12 are underfilled, have less than 12.15 ounces. So we're going to piggyback off of the answer to part A, and we're going to think of a situation in which the first can that we pick randomly out of 12 is either underfilled, so it's like 12.15 ounces or less, or underfilled complement. And then the second can is either underfilled or underfilled complement. So we could very reasonably define a random variable x. Say let x equal what? It's Does this feel like kind of a normal model situation, a binomial?
I sort of felt
Or
like
geometry.
it's like a binomial. If you're
It
just-
does have that binomial feel. It looks like the kind of binomial model where we're going to take a sample of 12 items, and the probability of, we'll say, success is underfilling, is 0.3605. So I think that's the model. We need a variable definition. Let x equal what? Do you have a sense for how we could define this random
Number
variable?
of cans out of 12 that have less than
The
12.5
fixed
ounces.
number of cans.
So the number does imply, since we're not saying first, it's implied fixed, but if you want us to say fixed, that's awesome. So the fixed, number fixed is optional, fixed
I didn't write that.
number of cans out of 12 that are what, overfilled or underfilled?
Under.
Less than.
Yep. That's we're defining success as underfilling that are underfilled. So we have a model selected, a random variable defined, and then a probability. What are we looking at? How are we gonna sum up this probability question? We're looking at the probability that x is what, Lydia?
I'm thinking x is greater than 4.
Yeah, greater than 4, and then for the
Yes.
for the purposes, way to go, Lydia. For the purposes of the calculator, we usually want to have a little bit of glitchiness. I think I'm going to save so far. So
Great
Good
idea.
idea.
Mr.
we want
Royce.
greater than or equal to for the purpose of the calculator. So that's greater than or equal to 5 cans underfilled. Oh, by the way, I mean, someone who's like really on top of it says, okay, it's a binomial model, so we're going to write as many triplets as we need. Actually, the x equals 5 triplet, the x equals 6 triplet plus dot, dot, dot. And then, I mean, this is good practice for those of you who might be doing the makeup quiz. The makeup test for Unit 7. By the way, if you are thinking of doing the makeup Unit 7 test, you might want to let me know before you go today. And remember, the podcast notes, the instructor podcast notes with them, you do Tuesday after President's Day. Anyway, you can fill these in. But on your calculator, you want to type in all this business. Instead, you can just do 1 minus binom CDF.
Yeah.
Of national 12, public 0.3605. Cradio would be what? Greater than or equal to 5 is the same as 1 minus x is less than or equal to what right-hand boundary? Would be 4. So this is how you're typing it into the calculator to get the answer to part B. Now for part C, that's the first problem on the homework. It's the only problem on the homework where you actually have to use the central limit theorem, the fundamental theorem of statistics. And
I did
again,
that.
how disappointing it would be if we learned all the statistics and we realized we can only use it when the underlying population is normal. Thanks to the fundamental theorem of statistics, the central limit theorem, we can apply statistics. We can apply the normal model to any sampling distribution
Yes,
of
we
sample means and
can.
proportions, even if the underlying population is not normal. Go ahead.
Can I get a Band-Aid for the nurse?
Yeah, go ahead. Right
And I
across
hope
the
you
way.
feel better.
Yeah, my face.
So-
I hope you feel better now.
Here, we're going to be using
Jen, I'll miss you.
another standard for rejecting the null hypothesis. We're going to reject the null hypothesis if the sample mean of the volume of these 2 cans is less than 12.15. So the sample mean of all 12 cans is less than 1. So we need a model. To answer a probability question, we need a model. Otherwise, we won't know what decision to make. This will be a normal model with a mean of 12.2. What do you recommend the standard deviation of the sampling distribution of sample means model be?
Wow.
Mm,
How's your kid?
Lydia,
I'm taking 0.14 over this. Oh, wait. Well,
Over this-
0.14 over the square root of 12, which is 0.04.
about 0.04. You remembered to divide by the square root of the sample size. That's right.
Wow.
Lydia remembered that the standard deviation of the sampling distribution of sample means is the same as the standard deviation of the population divided by what? Conceptually and verbally, it's what? Divided by
The square root of the sample
square root of the sample size. So that's the basis on which you would get an answer to part C, because we've got 12.2 as the mean. We're finding what's the probability that the sample mean will be less than 12.15. That would be, look, if our sample mean is only 12.14, we're going to reject the claim. There's something wrong. The mean fill must not be 12.2. I mean, it might be, but we're going to conclude, we're going to declare there is sufficient evidence to conclude that the true mean of this filling machine is not 12.2 ounces.
Yes.
So, you have to use a normal CDF to get the answer to this one, but do you have any concept questions on the homework that was due today before you turn
I felt
this?
very good on the homework. Thank you for your time and effort in teaching us the central theorem.
Central limit theorem. My pleasure. Yeah. Well, if you don't mind, go ahead and turn the homework into me now. I'm just gonna turn it into, you don't have to stand up and tire out your legs walking all over the place to find me. I'm just gonna find you. All right, so today, would you please take out the handout? It was the part 2 of 4 handout. We're going to look at the apples problem. It's the last one on there. How do you like them apples?
Apology.
So, I like having, so, right, so we have part 2 of 4.
Are you actually?
Just, as you page to the back of that handout, looking at the apples problem, it's gonna be a little bit of, all right. So if you can imagine that a truckload of apples is coming up to, let's say, an applesauce factory.
Oh,
So they've got
wow.
truckloads coming in almost every day, truckloads of
Applesauce
apples.
is so good.
And when the truckload arrives, they've got to decide, are we going to accept these apples? Or are they bad apples? So instead of looking at every individual apple in the truck, which would be a huge waste of time,
Of course.
we're going to take a sample,
It's a basket.
a representative sample, maybe a random sample of 150 apples. It's selected and examined for bruises, discoloration, other defects.
What if there's a warning?
Discoloration's like, oh, I'm not gonna eat that apple because it's bruised. That's such a first world problem, isn't it? Oh, no, I want a perfect apple. Maybe my favorite brand of apples. I mean, it used to be McIntosh when I was a kid, and I switched over to Honeycrisp.
Yeah.
Oh, Honeycrisp.
And they're super expensive, but boy, are they good.
Granny
And so-
Smiths are just better.
They're good for decoration. So the whole truckload, the entire truckload will be rejected. So,
So do they throw all those apples away?
so then, well, or the
Or do
truck,
they feed us like the pigs?
the owners of the apples will then try to sell them to someone else, maybe for a different purpose, instead of
Like what if they
applesauce.
like feed them pigs?
Maybe they'll send it like for animal feed or whatever, yeah, so.
Perfect.
So the whole truckload will be rejected
Feed it to
if
pigs?
more than
Yeah.
5% of the sample is unsatisfactory.
Yeah, exactly.
Okay, so, please note that this phrase right here is a peek behind the curtain, all right? So, this is an important phrase. This is the God's eye view phrase. And after chapter 18, they won't give you this information. They will not give you the peek behind the curtain. So, please make note of it, because that's significant. That's a signal that you're in chapter 18, which is a very theoretical chapter. They're telling you the truth. The people at the applesauce factory don't know the true proportion of apples that are bad. This is a truckload of bad apples. I don't know if you've ever encountered bad apples
Yeah,
before.
we got class number 5.
This is a truckload of bad apples, but they don't know that. For concept development, we give you a peek behind the curtain, and then after chapter 18, the test is 1 week from today. After a week from today, no more looking behind the curtain. They're not gonna give you the true proportion of something. They're just gonna say, look, if our sample has more than 5%, then we're gonna reject the apples. Now suppose that, what's the probability that, perish the thought, that the shipment will be accepted anyway? What percent of the time does our decision-making method fail, and as a result, we end up purchasing bad apples? Well, wonder if the colors are okay here. We have sometimes a blue and green. Excuse me.
You okay, Mr. Royce?
I mean, I feel fine.
Would
Just
you
that
like some
something's
water?
Are
happening.
you emotional?
I need to
Something's
give you a
happening
glass of
with my
water.
voice.
You need to, Mr. Royce.
So, what you're offering me a chunk of rose?
I was
That might
offering
fix
you a
it.
glass of water, actually.
Okay, yeah, that'd probably be better. No, I'm fine. Just, one of those things. Now, a random sample of 150 apples. What is the word picture that's guiding this? Are we talking about word picture 7 or word picture 8? 'Cause we're-
Seven.
Yeah, because we're
Seven.
gonna look at a sample proportion. So the word picture that's gonna guide the construction of our essay is word picture 7, which is all about a sampling distribution of sample proportions. And recall that word picture 7 has an independence assumption, which we ordinarily think of it as the blue part of the word picture, and it also has the sample size assumption, which we do that in green, sample size assumption. There's one condition for making the independence assumption. We said condition 1 was that we have either a simple random sample or a representative sample, but they said it's a random sample, so we know that the randomization condition has been satisfied, so we are justified in making the independence assumption that the outcome of all 150 apple examinations will be independent of the outcome of the examination of the previous apple. So independence is okay, we're good on that. Sample size assumption has 2 conditions. Condition 1, the 10% condition in green. Condition 1, condition 2, so. Now, this solution could be improved a little bit by actually stating explicitly the assumptions that we're making. So we'll see that in some of the other examples. That there'd be a way to improve on the notes here, but look. All 3 of the conditions are met. The blue condition is met, the 2 green conditions are met. Remember, sample can't be too big, it can't be more than 10% of the apples. They don't tell you, notice they don't tell you capital N. They don't tell you how many apples are in the truck. We just have to use our imagination. Say, come on, 150 apples, that's less than 10% of all the apples on the truck. All the apples on the truck. So that's where we're a little bit loosey-goosey here with the numbers, and they don't always tell you capital N. Now, how about condition 2 in the sample size assumption? Condition 2 from the word picture, you know that, sample can't be too small. MP's gotta be greater than 10 and NQ's gotta be greater than 10. And sure enough, N times P, 150 times, 150 times 0.08. 8% of 150 is 12. 92% of 150 is 138. Those are both greater than 10. So, it's a good thing we learned word picture number 7, because it tells us that we're justified in making the independence assumption, sample size assumption. Therefore, the sampling distribution model for P hat is normal with a mean of, hello. Yeah. I mean, if you want to take notes, you can, for the purpose of the sheet. So with a mean of what is the mean going to be? What's the mean of the sampling distribution of sample proportions going to be?
Equal to the true proportion.
Yeah, the true proportion is 0.08, which raises the question, what if we don't have a peek behind the curtain? Then what are we gonna do? Well, you'll
Learn the
have,
next unit.
that's what you're gonna learn in the next unit. So, but we're gonna handle that differently, and notice, this formula is gonna be a little bit different next unit also, because we won't have access to P and Q. When we do have access to P and Q, we can just go, boom, there it is. So this is the model we're gonna use. So would you please finish up model mechanics in conclusion?
Oh
Would
my.
Would you please take the space that's provided there to find the probability? So have at it.
I think I can do that for you, Mr. Royce.
I think I need a calculator for this.
You can do that, but all I ask is that you draw that bell curve first. So in the space provided, draw the bell curve for the model of the sampling distribution of sample proportions.
Funny guy. Have you ever considered being a comedian, Mr. Royce? Have you ever done a show? Like a stand-up show?
No.
I think you should. You'd do very good in Mr. Rose.
Honestly, you should be the coach of improv.
That would actually
I
work.
actually did do theater for 4 years in college, so.
Math is a performance.
Math is not a spectator sport, it's a performance.
Yes, sir.
But that would make it, okay, yeah, interesting. Okay, so,
I got the answers, don't worry.
If there's anything that you
I don't have answers.
Mr. Royce,
yes,
I was conspiracy theory.
you see how is conspiracy?
No, I have a conspiracy
Oh,
theory.
yeah. So, are you willing to share?
Central limit theorem. The acronym is CLT, which is like basically the same as cold.
it's
So
so
what if
cold.
stats is a cold?
Did you say it's basically the same as Colts?
Yeah. Like a
What
cult.
if stats is a cold?
Oh, Colts,
Cult.
Colts.
No.
What if stats is a cult?
CULT.
Yeah,
The
cult.
acronym would be C.
CLT, which is like the same as cold.
It's just basically.
I found .08828, Dan. I
That's
don't know how
interesting,
I found
because,
it.
I mean, I do sometimes frame statistics
As
as
a cult.
postmodern
Inclusive.
Bible, it's like an alternate. Because people who reject the Bible say, I'm not gonna get my truth from the Bible. So you really have nothing else other than statistics to rely on.
What about cows?
Turn the tables.
They also
interesting thing is
go
that
on.
the scientific method, which is at the basis of statistics, was born of the mother of Christianity. You really don't have a
You're
scientific
wrong though,
method.
man.
So they might think they have some sort of cult-like alternate religion, but it's really based in biblical truth.
It's based on Vega.
Do you think Valentine's Day should be celebrated, Mr. Royce, or not?
Do I think what should be celebrated?
Valentine's Day.
Oh, Valentine's Day. I mean, that's one of those things that probably could be some thought to. I mean, I've never really had a problem with
You know St. Valentine, what he did?
well, you know, what, perhaps we can talk about that later. I'd hate to get
He
behind.
saved
on it.
little girls from sex trafficking. He like bought them out of it.
That's
So
just
he's a
like
great
the
person.
right thing
Not
to do.
martyr.
All right, so let's take a look at this. We have, in fact, it's possible
Yeah, we did.
to kind of like wipe this out using my big white wiper outer.
Wow.
And, hello.
Oh, goodbye.
Neither did I got distracted by the call.
Now, probably the hardest part of the model is to write down the title, because as mathematicians, we're committed to not ever engaging in meaninglessness. I mean, it is one thing to say it's a normal model with a mean of 0.08 and standard deviation of 0.0222. But it's another thing to say, what is this that we're looking at? This is a normal model, this is a normal model of the sampling distribution of sample proportions. This is infinite number of possible samples. It's a sampling ing distribution
Nice.
of sample proportions where, then last period, it was, who was in this? It was Nate Gurley who said, well, what's a let statement for p hat? What really does p hat represent? If you had to tell someone what that p hat represents, what would you say?
The mean of bad apples.
It's the proportion of bad apples in what? In the truck?
In the
In
sample.
the
In the
100.
sample, it's a proportion, so it's a sampling distribution of p hat, which is the proportion,
So good.
the proportion of bad apples in the sample.
That's what that was.
Let that out.
The proportion of bad
Tell
apples.
us that you're gonna get a bouquet of flowers.
Yeah, I was gonna try to get a bouquet of
Sample.
flowers from
Okay.
Mr. Royce for Valentine's Day. They didn't let
0.08.
me.
Now, where did you shade this bell curve?
On the like the left, to the left.
Left of what?
The
0.05.
mean.
Like
Point
all
oh
the way
five.
to the
You
left.
see,
Coach.
even though it's 8% bad apples, some of the samples, some of the p hats will be 10% bad apples, some will be less than 5% bad apples. This is the nightmare scenario. This is where it's a truckload of bad apples, 8% bad apples. In our sample, we have only 3% bad apples, so our conclusion will be we accept the apples. So there will be insufficient evidence to reject the null hypothesis that these are good apples.
Some
So
of accepting apples.
yeah. So we are null hypothesis. We didn't really write that down. Speaking of that, H sub 0 is a symbol for hypothesis null. H sub naught, null hypothesis, is that, is that,
That is not respectful to all genders. I don't appreciate it.
so, yeah, so let's just think about this. What would the null hypothesis be? Well, actually, the null hypothesis is that the apples are good apples. Which means that it's less than 5%, that basically that the true proportion of bad apples is less than 0.05. And so, yeah, we said up front that we're gonna reject them if it's less than 0.05. Now, our conclusion then is that according to the normal model, probably that less than 5% of the apples in the sample are unsatisfactory. Is 0.008. It is a conditional probability, and that's kind of hidden here. That less than 5% of the apples are unsatisfactory. That's the eyeball statement. This is what we observed. What they didn't say is, given that in reality 8% are bad apples. So this is the brain statement, the brainstem statement, and this is why I'm actually hesitating on writing out the null hypothesis, because the null hypothesis is the belief, but in the real world, since we don't have a peek behind the curtain, we don't really know. So that's why we're just in some dicey territory here, because we're in chapter 18 in terms of how we would really do the null hypothesis in the real world. So, but that is in this problem, the null hypothesis is that it's really pointless. This indicates that if the random sample of 150 apples is taken from each of 100 trucks, each of which contains 8% unsatisfactory apples, then due to natural sampling variation, we can expect about oh yeah, we can do this. So we have this new z-score formula. Do you remember it's p hat minus p over the square root of pq over n?
Yeah.
So probably a lot of you already did 0.05 minus 0.08 over that 0.0222, which we already calculated. What z-score did you get for this thing?
I got like negative 1.3514.
And when you did normal CDF of negative 999, counted this, what proportion did you get?
I got the same thing when you got on the board already.
Which is what?
0.088.
Really? It's 0.0888? So it is
No,
about
just like 2 eighths.
eight. So it's about 9 of the trucks will be accepted. Anyway, if we take 100 trucks and 8.8% or about 9 of the trucks will be accepted anyway. So our method looks like it fails about 9% of the time. And so we just have to be willing to just plan for that. Sometimes we're gonna get a truckload of bad apples, 9% of the time. Do you have any questions on the apples problem?
Why is your, like, the marker so thick right now?
See, I can select the thickness right here. I usually teach on this first thickness level, but I can go 2, 3, or 4, like, in fact, I could even do like the top thickness level. Get ready. Okay. The wonders of the Promethean board. But it's kind of like if I put it in the middle, then I get this thickness. But if I pick like the highest one they recommend is this thickness right there, which yeah, that's
Can
reasonable.
you do class at the highest thickness just one day? Like blow it all the way up?
Can you do
Wouldn't
that
that
on
be
a
kind of fun?
smartboard?
That's a fun question. Yeah, what? I'm sorry?
Can you do that on a smartboard?
Yeah, I guess I'm just so much more familiar with the Promethean boards than, I've like used a smart board.
Which
They
one came out
had them at
first?
Wheaton Christian Grammar School. And I did a presentation over there once a few years back and I had to use a smart board. But
When did you do a presentation over there?
when did I?
Yeah.
Oh, it was for teachers. It was for teachers.
I didn't see you.
Yeah, so.
Come listen to
All right, and now, the next part of the list, let me pause this. Now, would you please just use page 1 as a little reminder to yourself that at some point next week, probably on Wednesday of next week, I'm going to quiz you on word picture 7
We
Oh,
have
it's
class
thick.
on Wednesday, Coach.
and word picture 8. So yeah, actually block day, so Thursday.
We're not school.
Yeah. So, word picture 7 and word picture 8 will be the subject of the quiz. So I would recommend that you rehearse word picture 7 and 8. Now, it'll be a 2-part quiz because on the back of the quiz, you'll, like on the front, you'll put word picture 7, so you have to fill in, you know, the independence assumption, sample size assumption, all the conditions for those. You won't have to use like the colors that I use in class, but you'll have to get the content. You'll have to get the mean and sampling distribution of sample proportions, the standard deviation of the sample distribution, sample proportions, all that stuff. And for word picture 8,
Yeah, me too.
instead of the theme being sample proportions, it'll be sample means, and you'll have to do all that. But on the back, there'll be a blank sheet of paper. On the front, you're gonna write word picture 7 and 8. On the back, you're gonna write out the central limit theorem.
Oh, wow.
All 3 statements, including the asterisk statement. So all 3 statements on the back, the central limit theorem stands for central limit theorem. And so yeah, that's next Thursday, test is next Friday. Now, let's start with the apples problem. And it's amazing, it's like, how did we get to the very last lesson? We just started central limit theorem this week. I think a big part of how we've been able to learn the central limit theorem so quickly is
The applet.
this applet, because once you see this population, and first, my 5th grade class really wanted to see that one, and if you got a population that's
cool.
you know, there's a heights of people, lots and lots of people who are super short, and you know, there's a whole sector of people that, and then if you take samples of size 2, do an air trace, quick air trace of what the sampling distribution of sample means is gonna look like. There it is. I saw a student go like this, like a larger groups in the middle, because this is a sample size, and sure enough, about 25% of the time we're going to be picking 2 short people. Average will be short. About 25% of the time we'll be picking 2 of the taller people, but sometimes 50% of the time will be 1 tall, 1 short, or one short, 1 tall, and so we get a lot in there. We saw it even more vividly, but as n approaches infinity, what is the shape of the sampling distribution approaching? The shape becomes more and more normal.
That's so cool.
And so, yeah, we have been learning statistics all year, as was mentioned by one of you yesterday, but we can't really apply it to lots of situations and really say, hey, this is worthy of being an entire branch of mathematics unless the central limit theorem is true. So thanks to that app, we'll go back and play with it. And
I did.
so, oh, you did? You actually went and used it? Oh, you did? Okay.
I
But
used
you're
Tennessee.
going to, right?
Of course.
I use Tennessee.
And listen to the podcast.
And listen to the podcast, that's right, because if you want to do the makeup Unit 7 test in a couple of weeks, then just take notes on podcasts for chapters 16 and 17, turn that in by Tuesday. Were you going to say something?
Yeah, I said I do the Tennessee thing. What do you like more, the Tennessee or the applet?
Right, because in calculus, we have an applet from University of Tennessee, yeah. I like
one's
this
from
one,
Greece.
this one we just saw, the stats one a little bit better. Because the one for calculus, that's stressful,
Yeah,
it's stressful. Especially if you go through, if you have to go through like all 8 incorrect answers before you finally get to the correct one.
Yeah, that's
Yeah,
not.
it's humiliating. So, no,
I'm
it's fun, it's
humiliated
fun.
every day stepping into that class.
So let's take a look at what's going on here. And we are on, not the potato, we just did the potato chips problem, didn't we?
The apple problem.
Oh, yeah, we did the apple problem. Okay, so now it's time for the potato chips problem. Here we are, number 48, page 2. The weight of potato chips in a medium-sized bag is stated, we want to have integrity, we want to say things that are true. It's really can't possibly be exactly 10.00 forever ounces, but it can be close. We want to shoot high, aim high, so we don't lie. And the amount of the packaging machine puts in these bags is believed to have a normal model with a mean 10.2. So that's our null hypothesis, essentially 12.2, and a standard deviation of 0.12. So we'll take those as exact God's eye view. What fraction of the bags sold are underweight? So just like on the homework that was due today, this is a semester 1 unit 2 problem. So go ahead and try to knock this one out using your calculator. Try part A on your own. I'm just going to pause the camera as I try to see what you come up with.